should be able to see my screen now. Yeah. Perfect, guys. So as I told before, I'm not really enjoying making sites, so I create like a little bit of system how I can just create one site or like several designs eventually, and they just quickly modify them so I can have a different width, different hinges, different length, and just to basically make it as fast as possible and play with the fronts because that's more fun. So we're gonna start as usual. Like I'm always starting with my stock material. So I always need to know how big I can make the sides and if they will fit the material. So I'm gonna start here with a sketch, put it on as usually on that little square, and create the rectangular in a shape of the stock material. And because I'm always shooting material in a 20 mil or 30 mil width, so I'm gonna make that one 20, and most of the time the length is 160 because that's most of the stock material I'm receiving, so it's 160 till 170. So let's start with 160. So this is gonna be my stock. I'm gonna extrude it just literally almost nothing, just like a almost film, so 0.01, and I'm gonna start playing with this. So on this one I'm gonna create another sketch, and I'm always it depends like what kind of arms you're doing. So I can first show you if I have arms that they are symmetrical, so you can just basically cut left and right the same shape and then just do a different engraving. And then I'm going to show you how to make arms which are not symmetrical. So like if you imagine the Ray-Ban arms when they have that little hanging bit underneath of the arm. So this is going to be the symmetrical one. And I'm always starting with center line. So I'm going to select here the line. And if you see here this edge, if you go along the edge and not pressing anything, when you are close to the center, it's going to show you that little triangle. So it means that you are in the center of the line. And I'm going to create this horizontal line across the whole stock material. Normally, when I'm doing some simple arms, I'm just doing this kind of shape when I'm going with a straight, then go a bit lower, basically under a certain angle, to taper the arm, then go straight again, and then create some sort of basically end like the tip of the arm. So let's say something like this. So it was just all these 1, 2, 3, 4, 5, 6 lines were done with a line function. And in this case I'm going to show you how to like you can do this. This sketch is going to be quite complex, but it's going to be afterwards super easy to modify it afterwards. So we're gonna put a lot of dimensions to it, and you can easily change them by just typing a different number. So normally I will go here to the function sketch dimension and tell first that this straight line I want it always, let's say, 50 millimeters, and then I know that I want basically the area where it's tapered and when it's thin, when you start bending the arm. I'm normally doing this like from this point where it's starting to be tapered till the end of the arm. I'm doing usually 50 millimeters, so I have a little bit of space and then basically bend it and have maximum like or approximately 35 millimeters the hanging bit behind your ears. So this is going to be 35. Sometimes move a little bit when I do the sketch for the first time, so I can just move it back like this, and then basically now I have this beginning and the end I have locked, and now I will create 1/2 of the hinge. So here I'm gonna create little just 3 lines. This is gonna be the half of my hinge. And eventually when we do the mirroring, I'm going to show you how to give this dimension. So this is one thing, and this is kind of the super basic shape. And now I will do the mirroring. So this is this function, mirror, and I'm going to select this line, this line, this line, this, and these three lines on the hinges. And my mirror line is going to be the center line, center horizontal line. So it's going to help you to visualize how the arms are going to look like, and you can still, just by dragging these points, you can just change the size, or you can just go to sketch dimension and select this line and tell it that you want this to be, let's say, 10 millimeters. And it's going to always change the width, and it's going to be perfectly centered. So if you have the wire shoot in the center, so there's no chance that the wire is going to be on the top or the bottom. Then I'm going to select the tapered area, which needs to be quite thin, because if it's thick, it's quite pain to bend it behind the ear. So normally I'm doing something between 5 and 6 millimeters, because that's the easiest thing to bend. So let's say 6 millimeters, and it sometimes do this kind of thing. And I can now, this is like a quite long and tapered area, and also here, and we're gonna put the dimensions to hinge. So I know the width of the hinge I want to use is gonna be 4 millimeter, and the length is gonna be, let's say, 8. And I know that I wanna start the hinge. Normally, because if I have a stock like this, I'm always keeping the hinge, the start of the hinge 6 millimeters from the end of the arm, so I have a little bit of area that I can do the mitering afterwards. Yeah. It's quite important to have the hinge locked like this. If you see that it's all black lines, it means that it's all have dimensions. Sorry, I'm gonna mute them. Sorry. And yeah, so now basically the hinge is locked in a place, and now from this point, when I have this, I can change the overall length of the arm. So as you know that normally when you have that little number of the length of the arms, it's measured from the beginning of the hinge, or from the screw till the end of the arm. So I can make this dimension and put, let's say, 140. And now I'm basically in a kind of position when I have arm, one design of the arm, and if I want to change it for the different frame, and I know that it's going to be small frame for for kid, or for ladies, and it needs to be shorter, I can just literally just type here 135, and it's going to change the size. So you can always play with this kind of stuff. And also, if it's gonna be a frame with a smaller lux, and it doesn't need to be 10 mil, you can just change it to 8 here, and all these things is gonna be always locked. And if you want also this end of the arm to be always the same size, you can just add a few more dimensions here to, let's say, the width of this end. I want this to be always 8, and overall length of this bit I want 6. So now if you change it to 145, it's just gonna always stretch the arm and nothing else will change. So you can just play literally with any size, and it's gonna be just changing one number, so you don't need to design much. If you want to change your hinge, if you want to use a wider hinge, you can just, instead of 4 mil hinge, you can use 5, and then just change it again with one number. So the more you're gonna play with this sketch, then it's gonna be much easier to modify everything. Now we're gonna go to extrude, and we're gonna extrude this arm. So I'm gonna select arm itself, and it's gonna go 4 millimeter high, like this. And this is the recess for the hinge, and I'm gonna add 3 millimeter because I want it to be slightly, 3 millimeter, slightly recessed. I'm gonna use the function fillet here and just make here the rounded edges, so it looks more like a recess for the hinge. So now basically you have your arm, and if for example if you have a collection and you want to use different fronts and you just want to use all the time the same fronts, you can just modify it according to your frame. Just go back to you have here your sketches. So let's say this is going to be stock and this is going to be your arm design. So if you edit the sketch again, you can just change, let's say this to 4 millimeter, or let's say 4.5 mil, and it's going to change that. Or if you want to change to 145, it's going to give you this length. You can always you can play with all these rounded edges in your first sketch, but you can also do it here in a 3D operation. So you can make the edge here and here rounded, and don't worry, even now it looks like, because we make quite a harsh transition just with the lines, so you can see it now that it doesn't look very smooth, but when you actually make the arm itself, it's going to end up being absolutely seamless, this whole connection. So you can just see it now, but eventually it's not going to be visible at all. So that's one thing, like how you can quickly design your arm. And the best way is, I'm going to now show you the next steps, how to prepare yourself a G-code for this. And the best way afterwards is just basically create one design of the arm and then copy the whole thing and redesign it, and have create yourself a library of different designs, and then you can just design the front and then find out the best arms that will probably fit the design of the front, and then just choose it, a little modify the width, modify the length, modify the hinge, and you have everything else immediately done. So this is basically one arm, and normally I'm doing them, making them both, because I'm gonna have an engraving on a left and a right, so it's best to have two of them. So what you can do is, normally I go for here to modify, to create, and mirror the whole thing. So press mirror. It's asking me here to select the body. I'm gonna select this, and the mirror plane is gonna be that it can be actually this plane, or you can click, if you zoom a lot in, you can just click on this edge, and that's going to give you the mirror side. Just here, when it's asking you if you want to join the operation, say that you don't want to join it, you want a new body, because you just want to have them separately. And you have a left and right, and normally I just don't like when they are touching each other, so I go here to bodies, select the second one, and go here to modify and move or copy, or you can press M and then just make a little gap, but you don't need to do that. But I just hate when I cannot see the gap between them. So this is in this point you have your 3D model, and we can now go to manufacture. I'm gonna first show you how to do the engraving. We need to create a new sketch, and we're gonna put it on the top of your arm here. Let's say on this right one. So it's gonna be engraving right. And here, if you roll down the create, you have here the function text. So you can just now it's basically asking you to create a little box. So you just create some box here, and you can type here whatever you want on your arm. So it can be, let's say, brand name, and here you can choose the font. It's basically link to your computer. So whatever, whichever fonts you have in your computer, you can use that. So if you have some already, you have a font for your brand, you can just choose that, or you can choose from thousands of fonts here. I can choose just a normal Arial, and here you can choose the size of your font. Normally I'm not going smaller than 2 mm for the engraving, because it's a bit tricky when you do it on CNC. To make anything smaller than 2 mm, it's going to be slightly distorted and it's not going to be very crisp. So for me, 2.5 is kind of best size. And if you press OK, you can just drag it wherever you want on your arm. There's probably a way how you can mount it exactly in the center, but normally I just eyeballing it where it's approximately in the center, or where I want it. And then now you go back to solid and press extrude, and basically make that whole engraving. You need to make it you need some depth. So I'm gonna extrude it minus, and normally I'm doing 0.4 deep, and that's gonna give you the engraving for your right arm. And normally I think it's like normally you have on one arm you have a brand name, on the other one you can have the size, or it can be the name of the frame. So we're gonna create another sketch and put it on the top of this arm. Again, here create text, and you're gonna create your box, and let's type frame name. Again in the same 2.5 mm, press OK. But the thing is that you basically, because it needs to be mirrored, so the best way how to do it is double click now on your engraving, on this text, and you can see here this little ball and a circle. So you just do 180 degrees turn, and that's gonna basically give you the engraving for the other arm. So now it's gonna be properly left and right mirrored. And you can do here extrude. Just click on a text till it's blue like this, and minus 0.4. You can always modify the text if you. I'm gonna just type it here. Engraving left. So if you want to modify it, here you have those two sketches. So you can go here, edit sketch, and you can just type whatever you want, and it's gonna make the same extrusion again. So if I type frame name number 2, press OK, and finish sketch, it's gonna make the whole extrusion with the whole text. The only thing that you need to do when you're changing the text, you just need to again drag it somewhere on the arm where you actually want your engraving. You can have it normally here next to the hinge. I always recommend you to have at least 5 or 6 millimeters away from the hinge, because when you're cleaning the engraving, or if you fill it with paste or something, if it's really close to the hinge, it's quite hard to clean it, and sometimes you're gonna scratch your hinge, or it's a bit tricky. So I always like to leave a little bit of gap between the hinge. And that's basically it. That's how you can make your arms and the branding. And now the thing is, we're gonna create data for CNC out of this. So you're gonna go from design to manufacture, and we're gonna create 2 setups, one for each arm. Even like if it's symmetric, you don't need to have like export afterwards the G code for cutting, because the cutting and the recess for the hinge is gonna be same for the left and right, but you need to export the different G codes for the left and right engraving. But I'm gonna show you how to do it. So we're gonna create a new setup, and automatically it will select everything what you have in your work area right now. but you just want basically work with the one arm. So here in the model, you can select just one body. So you just press select and click on one of your arm. And here if you go to, and normally it's always jump straight on the center of your material and the center of your arm. My recommendation is not, if you're doing arms, don't start from the center, because first of all it's kind of hard to find the center of the arm. I'm always starting on a left edge. So here you have an origin, and if you roll it down, you can click here on the model point box, and it's basically, I recommend you a few different points. It's usually the corners, top, center and the bottom, and the centers of every single side. So my point is always on the edge and the center of the arm. I found it quite useful, because even quite often when you do shooting yourself and you don't have every single arm the same length, or like if you don't have the same length of the material or something, it's always, if you set up this point, it doesn't really matter how long it's going to be your arm, because you're going to have more or less material on the end of the arm. So I recommend you to always click here. If you go on a second tab here on a stock, it's recommend you always to have a little bit of extra material, but you don't need that. So you can, instead of 1 and 1 here, you can have a 0 and 0, and you can see the stock dimensions of the material. It's 160, 20 and a 4.01, so basically 4. And that's it. Now you have the prepared setup, and now we're going to do the operations for milling of each of these things. So we're going to start with the hinge. For hinge, I'm using the function 2D bucket. So we're going to click on that. As the same way like we did the front, we need to first select tool. If you want, you can use the same tool that you are using for cutting fronts, which was 1/8 inch or 3.175. But normally I would recommend you, if you're cutting arms, go for the smaller cutter, because if you have a material like this, if you have a 20mm material, you need to have a space for the cutter to actually cut this shape. So if you imagine that you cannot fit much bigger size than, let's say, 60mm, because you need to have a 2mm on the top, 2mm on the top, on the bottom. So I would recommend you use a 2mm cutter. So we're gonna press here on tool and create a new tool. So it's gonna be again the flat mill, and here diameter is gonna be 2mm. Rest of these informations are not really important. Shaft not important, holder not important. Cutting speed, again the spindle speed, if your CNC machine is communicated with your G code about the speed of spindle, I would put at least 10,000 RPM for the spindle speed. And the cutting feed rate, with a 2mm cutter, I'm usually doing something between 500 and 1500 millimeter per minute. So let's be here a little optimistic, and let's put, let's say, 750, and the rest of the stuff is automatically calculated. So we can use this tool and select, and here in the geometry is asking us what we want to cut. So we want to tell the CNC that we want to basically cut on the bottom of this recess for the hinge. So it needs to be filled with blue and with a blue outline. The heights are not important here in this operation, and the passes, just be careful, because every time you use the 2D pocket function, it's always give you stock to leave. So I would now unclick that, because stock to leave is going to be, it's just basically going to make it 0.5mm less deep, and it's going to be 1mm overall smaller. So I will just delete it now completely. And here in a linking, there's one annoying thing, that is automatically give you helix, which means that the tool is going to go down very slowly into material. I'm going to show you. So you can see that red line is just going very slowly down. It takes absolutely forever and it's annoying. So if you go back to edit, you can keep the helix but change the ramping angle here from 2 degrees to 10 degrees, and it's going to be much faster. It will go down much faster and without potentially damaging the material or tool. So that's a function for the hinge. It's very similar to a function that what we're doing on the front. And the next operation would be the cutting the outline of the frame of the arm. So for that I'm going to use the same 2D contour that we were using for the lenses and for the outline of the frame. We already have here 2mm tool, that's good. We have here 750 speed, that's okay. And now I'm just going to select this line. And as you can see, normally if you wouldn't have this stock material on the bottom, it will cut also here on this edge, which is a bit tricky because normally you have here the wire or like maybe a little bit of sticking of the wire, and it's a bit tricky because most of the time you will break your tool on that area. So if you have a stock material and you click on the outline of your arm, it's just gonna cut here and here, like on the top and the bottom and around, but it's not gonna cut here on the front. So it's very safe for cutting. And with the passes, I will go multiple depths just to make sure I'm not, as it's 2mm tool, I wouldn't go deeper than the diameter of the tool. So I will go 2mm deep for each pass. And as you can see now, we have here 2 passes and it's always stopping on the edge of the material. So for me this is quite important because I don't want to break my tools. And the last operation here is going to be the engraving. If you don't have a CNC with the automatic tool changes, I would recommend you to do create now the code for the engraving, but never export all the operation in the same time. Always just, if you start cutting your arms, just cut them all out and then do the engraving afterwards, because it's gonna because if you need to change tool every single time between arms, it's gonna take you absolutely forever. And with the engraving, it's a bit tricky because Fusion is not kind of recognizing this kind of operation as engraving, so you need to little bit convince it that you actually want to do engraving, and you need to set up a new tool for that. So we're going to use the operation same as a hinges. It's going to be 2D pocket, and we need to create a new tool. So we're going to press here select and create a new tool. And then just quickly before, for engraving I'm using this kind of tools. This is very simple and super cheap engraving tools for any materials, for metal, wood or aluminium. I can recommend you to get this one, which is one side is flat and the angle of the engraving tool is 10 degrees and the tip of the angle is 0.1 millimeter. So it's one of the smallest one you can get. If you look at the Amazon, they are that cheap. I recommend you to get a lot of these, because every time you make even tiny mistake, or if you want to find the 0Z, you can very easily break them. So they are quite fragile. So, but Fusion doesn't have this tool in the, you cannot create this tool in the library. So I'm going to go back to 2D pocket, select, and instead of having the tapered shape, I'm just going to create a flat mill, which is going to be instead of the tapered, it's just going to be in a Fusion, it will think that it's just a tiny straight mill. So I'm going to use this and tell Fusion that the diameter of the cutter is going to be 0.1 millimeter. And you don't need to care about the rest of these numbers. For the cutting feed rate, it all depends how good is your CNC. If you have a very rigid CNC and very accurate, go fast without any issues. But because it's going to cut such a small areas, it's better to go slower and because you're going to get more accuracy. So I would recommend you to go 500. And also for the speed of your spindle, because sometimes if it happens with the different materials, for example, if you have a black material and you do engraving, because it has a lot of pigments, so sometimes it happens, it starts melting the material instead of cutting it out. So it just basically, it looks like it's cutting nicely your letters, but it's actually just melting the acetate right behind the cutter, so you cannot clear out afterwards the letters. So I would recommend you to go around 5000 RPM, not go faster, to prevent the melting of material. And that's it, you can accept. And we can now select, instead of 2mm, we can select the 0.1mm cutter. And we go to the second tab, and we need to select every single letter, which is a bit annoying, but it doesn't take forever. Just be careful when you're selecting the letters. Always be careful not to select the top edge of the letter, but always click on the bottom of the letters. So basically where you want your cutter to cut, so select always the bottom. It's quite visible because if you click instead of bottom, you're gonna click on the top edge. It's gonna look slightly different, so it's quite visible immediately how it looks like. So I'm gonna do it again. And you just select all the letters. And here there's one thing that I would recommend you, because it's a 2D pocket, so it automatically also give you to leave some stock. So you need to unclick that because you don't want that. And from the point of linking, sometimes if you have a typography with very thin letters, it's always good to remove leads into the material. So unclick lead in and lead out completely, so it will basically go straight to the letter and it's starting cutting. It's just a little tip that it will help you a lot. And if you press OK, now you can see, I forgot here, as the same as on the hinges, there's a ramping 2 degrees, but you can change it to plunge, so it will go all the way straight down into material. And now you can see that it's clearing nicely basically all the letters. So it's making more basically steps to just clear it, but I realize with especially with the black colors and very dark colors, it's good to have all these steps, so it's going to look nice and crisp when you cut it out. So that's basically engraving, and it's right here. There's a one trick, because I can show you. You can see, because it takes quite long, because as you can see, it's always cut one letter and it goes all the way up and then down, all the way up and down. So all these yellow operations are taking absolutely forever. So if you go back to edit, normally I would just change it for operation of engraving. And here you have the heights. We never so far opened that tab. So it's basically telling you that between every single letter is going to go 5 mm up, then down, and then 10 mm between the steps in the letters is going to go 5 mm up and down, and between the letters is going to go 10. So normally I'm changing this to 1 mm, or let's say 2 mm. Here I'm going to change to 1 and 1, and here thinking just clearance height, I'm just going to change to 1 mm. So it's now going to do just like literally small jumps between the letters, and it doesn't look like a big thing, but this can save you like 3 or 4 minutes on actually the whole process of engraving. So you can go from 7 minutes of engraving to 3 or 2 minutes. So now basically we have the whole arm, like a whole right arm done. And because you need to do the other one also, so you can click here on I'm gonna rename this one right. And if you click right button on this whole setup, you can press duplicate. And you have here now basically the same setup, copy paste. So I can rename it to left, and I just need to click right, edit, and tell him that we're not going to play with this body anymore. So I'm going to delete this, and I'm going to tell him that we're going to play with this one. And here again, edit. It's the same thing like when you're copying the setup for your front on another frame. So you just have here, you're going to select the geometry, delete the old one, click on a new hinge. That's done. Then you have a contour, again, geometry, delete, and click on the other contour. And with the engraving, the same thing. Click here, geometry, delete, and you're gonna select all your letters. Here, here, here. And you have the engraving for the left and right basically ready. So from this point, I would just I would use this as your template for arms, and every time you design a new arm, just do the 3D model and then copy all these operations, because you will know that these operations will work and it's not going to give you any issues. You don't need to play with all these setups that we did for engraving, like with the heights and everything. So you can always copy paste it. And if you have a new frame, you can just always go copy the whole arm, both arms, as when you have here your materials. Okay, class number 5. If I'm gonna save this one as a sites 01. Sorry, I think the screen disappeared, but I just save it here on the left side as a site 01. And if I'm gonna do a new frame and I know that I want the same design of the arms, I can just right click here on these arms, copy in the same folder, and basically rename it based on your frame. Open them, and if I know that this is going to be the larger frame and with the bigger lugs, I can just change it to 11. And I know I'm going to use 6mm hinges, and I have basically now new arm that I would spend some time to design it and then do all this kind of stuff. So in this point I can just literally just take it, modify whatever I need, and if I go back to manufacture, I already have every single step already prepared. So it's going to be much faster to get you started. It's going to take a while, probably like a month, to get all your designs of the arms ready, but it's going to be afterwards super quick. So this is how I'm doing my arms. Sorry for this design, it's not exactly nice, but you can just use your own designs and make something nice. And I'm going to show you now little advanced when you want to do the asymmetric arms. So I'm gonna start now with a slightly larger stock, and I'm gonna use the 30mm. So I'm gonna create myself stock material for 30mm. So it's gonna be 160 and 30. I'm gonna extrude it 0.01 and create now another sketch. And start with the center line, and I'm going to try to recreate that like a Ray-Ban arm that has that little hanging bits. So I'm going to start with a straight line, then do a little bit of tapering,
and then let's say it's gonna be like a little and I can make this straight and down. So I'm not gonna do mirroring now because it's not gonna be same. I'm gonna make this longer than the previously, and then this long hanging bit, and go back to the beginning. So now it looks horrible, but I'm gonna show you like a one trick when you're doing this kind of stuff, and you want to use the same function when you just change one dimension, and it's gonna be perfectly centered according to your midline. So if you press here the sketch dimension, and you wanna know that this end of the arm you wanna have 6 millimeter. So you can make it 6 mil. But now, as you can see, it's not perfectly centered to your center line. So there's a little trick. So if you press again the sketch dimension and you select the top line and your center line, it's gonna give you some random dimension. But you can click on that dimension and basically create equation, and here like a double click on the dimension, and then it's all selected. So you can now click on this dimension, and it's basically now know that it's looking at that 6 millimeter overall width, and you can just press divided by 2, and it's gonna center it perfectly. So if you want to change it to 5, it will automatically calculate that this dimension needs to be 2.5. So it's a little trick that it will help you eventually when you start playing with different shapes or more complicated shapes, that this will help you to not make a mistake. And we can do the same thing here when we do the dimensions. I know the beginning of the lock is gonna be 8 mil, and it needs to be in the center, so I'm gonna click on that bit, center line, and then instead of typing the number and divided by 2, I'm just gonna click on this dimension and divide it by 2. So I can just easily change it like this. And normally I'm just keeping these lines kinda loose, so I can play with how long I want this, and if I wanna make the hanging bit closer to the lugs or further from the lugs. And if you want, you can use here the function fillet and make it smoother, because this will be visible when you cut it out, and that's gonna give you like a sharp edge. So you can make here, let's say, large 30 mil or 150 mil radius. So it's gonna be much nicer, but sometimes it's making these mistakes, and that can be your end. Also, if you want this end with a radius, it's a bit tricky, because Fusion is not allowing you to do the perfectly radius. So you can just make here the fillet, and then let's say type 2 millimeter, and here also you can have a, let's say, 2 millimeter, and it's going to give you that end. We can make here the hinge, and again it's going to be a width of 4 millimeter and a length of the recess 8 millimeter. But as you can see, it's not sitting perfectly in the center, so I'm going to use the same thing. I'm just going to go from the top to the center and tell him I want to overall width divided by 2. Then best to put it 6 millimeter from the end of the arm, and here you can put the overall length of your arm from the beginning of the hinge to the end of the arm, 145. So this is going to be again all adjustable. So if you want to change the width, it's going to be this. Sorry, I came out of the picture. So you can change it here to, let's say, 7 mil, and you want a 135 overall. It's going to change the whole thing. And I can extrude it now. I can extrude this and this. 4 millimeter and extrude this 3 mm and create here a little fillet. But I would recommend you, it's a bit tricky, or it's a bit more engineering bit, because you can do the fillet here, here and here, and you can also tell him that you want this fillet to be changed based on the width of your hinge. So you can press the radius you want to have. I'm gonna click yes, and then if I click on this again, I want this to be size of the radius, basically the half of the width of the hinge. And the same thing here. Enter and then double click and then click on this dimension. But there's a problem, because Fusion hates connection of 2 radiuses. So normally what I'm doing here, instead of just I'm basically like instead of clicking just on this half, I'm just going to click on this half of the hinge, minus 0.1. And with this one I can click, I want the same radius here. So if you change it to 5 mil, it's going to change the perfect radius. This is a thing that you don't need to use, and it's a bit into engineering to just have this like a quite annoying equation, but sometimes it's quite helpful if you want to change this all the time and you don't want to type different things and you just want automatically to change everything. So this is going to be your right arm, and we can do the same thing with mirroring, selecting the object. Plane mirror is going to be here, that little edge. And as before, I don't want to do, I don't want to join them, I want to create a new body, and that's it. So you can just have this one, and I need to move them a little bit further aside. And yeah, that's basically like what I have normally in my library. I have 10, 12 different arms, and I'm not designing them anymore. I'm just going to choose the one from the library, modify it a little bit, change the engraving, and I'm done. Any questions, guys? Or was it understandable, or anything that I can explain a bit more?
What with the engraving?
Yeah.
It made sense, but I'm curious about the process with putting some paint in there, and then like, what do you rub it off while it's still wet, or do you know anything about that?
Yeah, there's a few ways how to do it. You can buy like a special engraving paste in France. They're making it in silver and in gold. It's usually quite good, and it's surviving quite well. But recently I had one frame that actually my mother-in-law was having the frame that it was made like this, and that engraving got completely moldy for some reason. I have no why, but the engraving basically starting to be moldy. So I don't think that this engraving is actually safe for the skin. So what I was doing before, my process of when I'm doing this engraving, I'm basically just, when I finish the engraving, I'm just rub a little bit of it's called like a dry paint stick, and I think they are using it for marking tires or marking some metals and stuff like this. It looks like a big ass
Like a crayon?
Crayon. But it's good, but it's still quite soft. So basically I apply this, then clean the surface, and then put a thin layer of super glue, which will basically create nice hard surface, and it's safe for the touching with the skin. And that basically kind of seal the surface, and you can sand it, and it's going to be, you can still feel that this is kind of 3D, but the surface is going to be absolutely flat.
And would that survive barreling, or do you do that after?
Normally I just put the crayon, then clean it, put the super glue, even with a little bit layer on the top, and then put it in the barrels. So the little bit of the super glue will be getting up in the barrels, and you can just sand it a little bit afterwards when you're finishing the arms.
Nice.
But
Thank you.
we're also playing with Kenneth. We are playing with the idea of using the nail polish, which is a bit tricky because it looks really good. It's super easy to apply. It's surviving really well. The problem is that you cannot dip your arms in acetone before barreling. So you just need to cut your arms and then put the engraving and put them straight in the barrels. Which means that you need to sometimes do a little bit more sanding because the dipping and acetone will get rid of some indentations and some like scratches. So it's not a bad process, and I'm still trying to figure out if there is maybe some other way. So I have now for testing some acrylic, a special acrylic infill paint that it looks super promising because it dries really hard and it's super easy to clean it afterwards. But I'm not sure how this will survive long term. So if you want a really engraving that will survive forever in a place, just use the super glue and put a tiny layer over your engraving.
Great. Thank you. That's great.
No worries.
I will be also ordering some UV cured paint, so I'll see how that goes and will let you know.
Yeah, that's also good because it's also dry completely hard, so it's easy to sand it afterwards.
I had a question just around how do you make sure that you get a nice fold in the arms so that they fold as close to the front as possible? Is that something you work into the design of the arms?
Not really. Like I'm usually choosing the hinges that I know that it will fold nicely, and quite often the very important thing that if you want to have a nice fold, it doesn't work with a flat frame. Normally it works much better if you have a little bit of base curve. It's gonna always fold nicely. And also, like if you have the hinges which are riveted, you can always adjust them to have a perfect pantoscopic tilt to fit perfectly. And when you fold them, you can tilt them a little bit because they have a lot of play and they can be modified using just a little bit. So you can just basically push them till it feels nice and folding nicely. But I don't do any prior design work to make sure that they are folding nicely. It's going to be kind of like a surprise on the end when I finish the frame if they are folding nicely or not.
Okay, gotcha. So more of a question of the curve and combination with that and the hinge.
Yeah. There are definitely some hinges that I like. They look great on the paper, that they're gonna look great and they're gonna be super easy to use, and they are folding absolutely horribly.
Okay, thank you.
No worries.
And what about engraving a logo, like a graphic design format?
Good question. It's normally you just need to create yourself a new sketch. So if you have a logo and somebody already created it in Illustrator or you have an exe file, you can always import it in your sketch and then change the size and then do the same extrusion, like a minus extrusion, and then engrave it out. So we did it, for example, like when I was doing the sizing of the frame. It's, as you know, it's normally the size of the lenses. Then there is a little square, and then is a bridge size. So I couldn't find anywhere in the symbols to have a nice square. So I always made the square in another sketch and make basically two squares and extrude them. So for the logo, it's basically the same thing. You can always export anything, or you can just, if you have something that simple, you can just draw it in Fusion and then put it in a sketch. Just wanna tell you that even when you don't spend crazy amount of time to find the perfect font when you do the engraving, because the font is not gonna look exactly as it's right here. It's gonna look slightly different. It's sometimes gonna be a bit thicker, a bit thinner. So don't get crazy obsessed with the perfect font if you're machining engraving, because there's no need for that. Anything else? Any? Yeah, okay. This is the way I'm saving time on arms.
That was a great video. Lots of really good tips, especially for designing the arms.
Yeah,
Everything.
like I'm gonna share these files with you on a group, so you can open them and see the, because if you open the sketch it looks a bit messy. If you see that there's a lot of numbers and everything, but when you start using it, then you will know that you changing this sketch, this dimension, and you change the size of the hinge, and you're not playing with anything else. Even there is 10 more different dimensions, everything else will change automatically. So there is still always, like, if you have more complicated arms you will do, there's going to be more issues to how to sort out that if you change something, it's not going to mess out some other part of your arm. So like if I pull this somewhere, it still probably work like this, but maybe if I go other direction, something got loose somewhere, and I'm going to completely break the sketch. But it's not happening very often.